Hello everyone. Today we will see some more problems related to the cables. Previously we discussed about the problem related to the combination of UDL as well as a point load. Today we will see another one problem. It is related to only the point loads, and the question is as follows. The cable is used to support six equal and equidistant loads. Keep it in mind, 6 equal and equidistant load over a span of 14 meter. Full stop. The central dip of the cable is 1.6 meter and the loads are each of 20 kilonewton. Calculate the length of the cable. Also calculate cross-sectional area of the cable if the maximum stress in the cable is not to exceed 150 MPa. So that's the question. Based on the given data, I drawn the figure, and a very important thing is the total span of this one will be 14 meters. So in this 14 meters we have to place the 20 kilonewton point load such a way that 6 point loads we have to place such that it should be at a equal distance, both from both at the supports as well as between the forces. See, that what I considered. See, the central dip also they are given 1.6 meter with respect to C, 1.6 meter, that is C is exactly at 7 meter from left as well as from the right, because we have supports at the same level. 6 loads I am considering such that in order to make equal, so if you accommodate like this, 2 meters from the support to this load and 2 meters from this load and then 2 meters from this load and then 2 meters from this two load. So everywhere it is equally distributed, so it is equidistant and the magnitude of the loads will be 20 kilonewton. So 1, 2, 3, 4, 5, 6 and 7 are the 7 multiplied by 2, it is 14 meter. With respect to this point, year to year it will be 1 meter, that what I shown here. Similarly, year to year it will be 1 meter. Total year to year it is 2 meter, that what I shown here. So the procedure will remains the same. Here also you have to find out the maximum and minimum tension in the cable. In addition to that, you can even find out the length of the cable by knowing that. In addition to that, even you can find out the area of the cable. So first step, it will remains the same. Finding the reactions. So we know reactions, horizontal force minus HA plus HB, that will be equal to 0. Then I can consider HA plus HA will be equal to HB, that will be equal to H. And vertical forces, VA moving upwards positive, VB moving upwards positive. All the 6 loads which are acting downwards, that is 20 multiplied minus 20 multiplied by 6 I can consider. And then moment at this point, then for year to year we know 2 meter, 20 into 2, year to year we know 4 meter, 20 into 4. Similarly it will goes on. So it will be as follows. I am considering f of y, that is VA plus VB minus 20 into 6. 20 is a point load, magnitude of the point load, and we know they are 6 numbers, so it is 20 multiplied by 6, so it will be equal to 120. And moment at A, 20 into 2, similarly it will goes on 20 into 4, all tends to rotate clockwise, 20 into 6, 20 into 8 plus 20 into 10 plus 20 into 12 minus of VB multiplied by 14, so you will get this value. It is symmetrical, so you will get the same values, VA as well as VB. And you came to know HA will be equal to HB, that will be equal to H. After finding VA and VB, next step is to find out the value of H. So in order to find out value of H, so I have to consider moment at C equal to 0. Any one of the side you can consider. Here I am considering RHS, right hand side. Moment at C equal to 0. 20 into year to year perpendicular distance is 1. Another one 20 into year to year perpendicular distance is 3. Another one 20 into year to year perpendicular distance is 5. Minus of this will tends to rotate anti-clockwise, minus of VB multiplied by ear to ear perpendicular distance is 7, plus HB multiplied by HB or H, both are one and the same, that what I told. H multiplied by the perpendicular distance is 1.6. Okay, it is as follows. Moment at C equal to 0 to right hand side, 20 into 1 plus 20 into 3 plus 20 into 5 plus H into 1.6 minus VB into 7. That will be equal to 0. In this equation, we know VB value unknown is H. For that, H will be equal to 150 kilonewton, that you came to know from the above equation. And we know T minimum will be equal to H value, that what I considered here. And T maximum will be equal to root of V square plus H square. So V square plus H square, we know V we have to consider only the maximum value, but it is symmetrical. So VA as well as VB, we got it as same, that is 60 kilonewton. So I consider the same here, root of 60 square plus 150 square, it will be 161.554 kilonewton. Okay, this is the total maximum tension in the cable. So length of the cable, for that we know span, that will be 14 meter, and we know central dip as 1.6 meter, and it is acting exactly at the center. That is it is symmetrical, and the loads are exactly at the same level. So the length of the cable, we have the equation, S will be equal to L plus 8D square divided by 3L. Substitute these values in the above equation, you came to know the length of the cable, it is 14.49 meters. Okay, in addition to that, we have to calculate the cross-sectional area of the cable. For that, they are given clearly that cross-sectional area, in order to calculate cross-sectional area, we know stress will be equal to force by area. Here force, in place of force, we have to consider maximum tension in the cable, and it should be divided by area of the cable. Okay, and they are given stress, that one as 150 megapascal. Then we know 150 megapascal, that we can write it as 150 Newton per mm square. That what I consider, directly 150 I considered. What I am doing is, we know maximum tension in the cable, that will be we know from the previous one, it is 161.554 kilonewton. This one is terms of kilonewton, and converting this one into Newton. Okay, so then it will be 150, that will be equal to 161.554 multiplied by 10 raised to 3. It is converted into Newton, whole divided by cross-sectional area, I am considering it as capital A. Then capital A you will get in terms of millimeter square, that will be 1077.026 millimeter square. So in order to get the diameter of that one, we know area of the cable is pi d square by 4, because it is in a circular form, so it will be pi d square by 4. So I am considering diameter of the cable as d dash. Okay, so we know area as 1077.026 millimeter square. So from this equation, unknown is d1 dash, that you came to know as d1 dash, that will be equal to 37.03 millimeter. Okay, there ends your problem. It is very simple one. If you know the concept, these problems are very simple. Thank you. We will see some more videos related to the cable in upcoming days. Thank you. Thank you.